Hello, my name is Zach Gibbs, and I'm a content developer within education services inside Juniper Networks. And today we will be discussing the DiffServ-Aware TE RDM Learning Byte. All right, so let's go ahead and jump right into the example. In the example, I want to focus on the topology on the bottom left here. And in this topology, we have 4 provider edge routers, PE1 through PE4, and 3 core routers, P1 through P3. So keep that in mind. And the other thing I want to point out is the shortest path through the network is using the P1 to P3 link. Okay, so with this, we want to establish 3 different LSPs using the Russian doll model, bandwidth model, so RDM. The first LSP is going to be a data LSP that goes from PE1 to PE3, and it's going to be mapped to CT0, so that's class type 0. And it's going to need 900 megabits per second, and the priority, the setup and hold priority, is going to be 7 and 7. Okay, so the next LSP is also a data LSP that is going to run from PE2 to PE4. Again, CT0 is what it's going to need, and it's going to need 100 megabits per second with a setup and hold priority of 7 and 7. Okay, so the last LSP is a voice LSP that's going to go from PE1 to PE4. That's going to use CT1. It's going to need 100 megabits per second and has a setup and hold priority of 0 and 0. Okay, so the other thing I need to talk about is the bandwidth reservations. The bandwidth reservations are configured as shown. CT0 gets configured with 900 megabits per second and CT1 gets 100 megabits per second. Now, you might know a little bit about RDM and you might be looking at it saying, well, CT0 gets more than 900 megabits per second because it can share bandwidth with CT1, and if you said that, you'd be absolutely correct. But this is what it's actually configured for, because we're configuring the scheduler that is associated with Q0, or the forwarding class that is associated with Q0, that is, with 900 megabits per second, and the scheduler that is associated with the forwarding class of Q1 to 100 megabits per second. So that's the configuration, and if you know anything about RDM with the bandwidth sharing, you probably know where this is going, but just stay with me in the meantime. Okay, so all links are 1 gigabit per second links, and so that'll be important. So between those two CTs, all the bandwidth will be taken up. So keep that in mind. Okay, so let's go ahead and jump right to the CLI. Okay, here is the CLI for PE1, and I do want to point out we will only be working with PE1 and PE2. We don't have enough time in this learning byte to configure all of the routers in this MPLS domain, so we're just going to stick with these 2 routers. So let's go ahead and jump into configuration mode. Go into the protocol's MPLS. Now, the thing I do want to point out before I get going is class of service is already configured on all the routers. We don't have time to jump into that, but just know that the class of service is configured in a way that CT0 gets 90% of the link and CT1 gets 10% of the link. So that would be 900 megabits per second and 100 megabits per second, respectively. So just keep that in mind. That's how it's configured. Now, we're using Russian doll model, so things are going to work a little different because of the bandwidth sharing that is allowed. Okay, so first thing we need to configure, well, let's see what's in here. Just an interface, that's fine. We need to configure the DiffServ-Aware TE bandwidth model. We do that with the command on the slide. We'll say bandwidth model, we'll say RDM. That's all we need to do there for that. Now we need to configure a custom TE class matrix. We could use the default, but the default won't work with what we're currently trying to do. Okay, so that's set DiffServ TE, and I believe that's, TE class matrix. And then we can choose the TE class. We have 0 through 7. We're going to set TE0, traffic class. We're going to set that to CT0. And we're going to set the priority to 7, or priority, got to set that first, to 7. Okay, so then we need to set TE1, traffic class, CT1, priority 0. So what does that mean? That means that any LSP that has CT0 as the class type and a priority of 7 gets mapped to TE0. And any LSP that has CT1 as the class type and a priority of 0 gets mapped to TE1. So that'll be important when we start looking at the traffic engineering database, so keep that in mind. Okay, so let's go ahead and commit that. PE2 is already configured for what we just did there. There's no reason to configure that again because, you've seen it once, you've seen it a million times, right? Okay, so with that, so it's configured. Now what we can do is we can look at the traffic engineering database to see how things line up. So run show TED, we want to use database option. Then we need to figure out which device or router we need to look at. The TED is the same on all the devices. This is the copy of the TED is passed around to every router in the MPLS domain. So keep that in mind. And so what we see here is we can use PE1 to look at what P1 has. So that's why we're just staying on PE1. As long as we reference the router ID, we'll be able to find it easily. The other thing I like to do is I like to use find to find specific links. Notice on PE1 that the shortest path link is that 172.16.10.1 IP address. So we can do that, and that'll find and put that output at the top of the list for P1 for that link, that is. Okay, so let's look at this. We can see here that CT0 has 1000 megabits per second and CT1 has 100 megabits per second. And you may say, whoa, we talked about CT0 is configured with 900, CT1 is configured with 100. Why does, and the links are 1 gigabit per second links. Why is CT0 show 1000, CT1 shows 100? That's more than the entire link. And the answer is because it's Russian doll model. CT0 is configured for 900, but it can borrow anything from a higher CT. So it can borrow from CT1, CT2, or CT3. Here we just have CT1, so CT0 can borrow the 100 megabits per second from CT1 as long as there's nothing CT1 that needs to use it. No LSPs that use CT1, that needs to use that. So that's kind of interesting how that works. That's how it shares it. Okay, so we look at the traffic engineering classes. We see TE0 has 1000 megabits per second available, and TE1 has 100 megabits per second available. It kind of matches up with what we saw with the CTs there. So let's go ahead and configure our LSPs. Okay, so this is the P1 to P3. So P3, got to enter the IP address for P3. We set the priority. We set that to 7 and 7, set up and hold priorities. Then we use the bandwidth command to specify the CT, which is supposed to be CT0. And then 900 megabits per second. That's 900 M. Let's go ahead and commit that and see how that has an effect on the TED. Let's make sure that's up. And make sure we're using that shortest path link. We're using, you can see that second hop shows 172.16.10.2. That's the shortest path link. Great. So let's go ahead and look at the TED for that shortest path link. We can see here that the TED shows, it still shows the CT has 1000 for CT0 and CT1 has 100. That's just what the configured or the actual bandwidth reservations are total. But we look at the traffic engineering classes, we can see that TE0 has 100 megabits per second and TE1 has 100 megabits per second. Great. So let's go ahead and configure that second LSP, that second data LSP for PE2. That's going to PE4. So the priority is 7 and 7. Bandwidth, we need to set that to CT0, 100 M for 100 megabits per second. Commit that, and you can probably guess from looking at the traffic engineering database earlier that it'll go over the shortest path link. See that it's up. And we can see through the detail output that yes, it's using the 172.16.10.2 hop, that's the IP address for the P3 router across that link. And so great. So let's jump back here to PE1, look at this again, and we can see that TE0 has 0 bits per second available, but TE1 still has 100 megabits per second available. Remember, I told you that it can share bandwidth, but if something from another TE, like another LSP needs the bandwidth, then it might not share it so well. So let's go ahead and configure that voice LSP now. So we're going to set this as going to PE4. Put the priority 0, 0. Use bandwidth. We'll say CT1, 100 megabits per second. Go ahead and commit that. Both of the LSPs are up. Let's look at the voice LSP. That voice LSP does show that we are using the shortest path. Now, one thing I do want to point out is if you look up at the data LSP, you might notice that it's no longer using that shortest path. The voice LSP, we can see it's using the 172.16.10.2, which is the shortest path. But the voice LSP is using now the 172.16.2.2 as the second hop. That's not the shortest path. That goes through P2. An LSP got moved, and it looks like that LSP was the data LSP on P1, or excuse me, PE1. So let's look at the bandwidth information. Oops, didn't mean to use that set command again. Won't make a difference. Okay, so here's the bandwidth information for that shortest link or that shortest path across the P1 to P3 link. we can see here that things have changed. TE0 shows 800 megabits per second available. That tells me that PE2 to PE4 data LSP is still using this link. And we can see that in TE1 that there's 0 bits per second available. That's because the voice LSP, which uses CT0, is going across the link. Okay, so let's look at PE2 real quick. We can see that that LSP is using the shortest path still. You can see that second hop uses 172.16.10.2. That's great. And so we know that the data LSP from PE2 is using the shortest path link. The voice LSP on PE1 is using the shortest path link, but the data LSP on PE1 is not. So let's, for one last thing to look at, let's look at the link that goes from PE1 to PE2. Okay, so in here we can see that, yep, TE0 shows 100 megabits per second available, as well as TE1. That means that that LSP is using that link. Well, we've already seen it's using that link, but we can see here that it's using that link and decrementing the bandwidth information from TE0. So that brings us to the end of this learning byte. In this learning byte, we discussed how to configure DiffServ-Aware TE LSPs using RDM, and then we demonstrated how to verify those LSPs using the RDM model with the Traffic Engineering database. So as always, thanks for watching.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Networks Certification Program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.